The main topics that we are going to cover today are the runtime fabric. What are its what is runtime fabric? What are its capabilities? What is the runtime fabric on the self-managed Kubernetes? And what is runtime fabric on the VM bare metal? So that is one of the aspects that we are going to cover in this talk. Then we are going to talk about our organization's VM bare metal architecture. In that particular discussion, I'm going to cover the current state RTF architecture, and then where are we heading in the future. And then my co-presenter Michael Brew is going to take over to the comparison matrices between different MuleSoft deployment options. What are the different aspects we need to compare whenever we are taking a decision, what kind of a deployment option we can choose. Uh, we will talk about the key features of the runtime fabric, how it makes upgrade for the runtime fabric easier, and how it makes it easy to upgrade the runtime version for any of the application. Okay, so thank you everyone for joining, and I'm one of the organizer along with BPS. I'm a MuleSoft mentor and LA Meetup group leader. I'm a manager of business systems engineering at Affolion. I don't think BPS is over here or Nikkei is over here. Let me take a look. Sorry, they are not here. So I'll continue. So BPS and Nikkei are other two meetup group leaders for LA Meetup group. Safe harbor statement. Both the speakers and the host are organizing this meetup in individual capacity. We are not representing any of our companies basically. This presentation is strictly for learning purpose only. Organizer or presenters do not hold any responsibility that some solution will work for the business requirements. The presentation is not meant for any promotional activities, just a safe harbor. Some housekeeping. I have started the recording for this meetup. This recording will be available within next 24 hours. I have opened the chat or questions tab. Please use that very as and when you have any of the question, and we will try to answer the questions. After this particular session, please give me the feedback. Give us the feedback. Rate this meetup session by filling the feedback form at the end of the day. We want to hear your feedbacks. Okay, before moving forward, I like to know a little bit about any of the attendees who are new to this meetup group. Anyone wants to kind of share some thoughts who joined first time here? Anyone? Abhishek, would you like to talk a bit about you and
Hey Rohit, hi. So I'm working as an associate solution architect in Apicero. I'm leader for Lucknow and Guwahati group, also a MuleSoft mentor. I write blogs. I'm a meetup speaker also, spoke in several meetup groups. So that's all. Thank you.
Ravi, congratulations for your kind of I looked in.
Yeah, congratulations, Ravi sir, for delivery champion. It's a great achievement and great thing. And most probably, like the best thing, like Ravi is one of the first person to achieve that. So great achievement, Ravi sir. Congratulations.
Ravi, would you like to share some thoughts, uh, some feedback on your journey? Okay, let me check. Uh, Shreyas, thank you for your question. I think it will be available in your email. The recording will be available on your email, and you can revisit it. And it will also be posted onto the meetup link, basically through which you would have kind of a subscribed this. So it will be available over there as well. Uh, has that answered your question? Perfect. Thank you. Let's get started a little bit further.
Rohit, sorry to interrupt, but like, is it possible to enable the general chat box also? Because Q&A, I don't see any chat for Q&A myself. I think only the organizer or someone can see that.
Uh, uh, I'm not able to sure where it is. This is the first time I'm using Meetup. Do you have any? Uh,
Mm, it should generally show you here, but I'm not sure because you can see all the chat what you get in the Q&A, but we are not able to see anything.
oh, sorry. Uh, the other leader
Okay,
is not here. Uh, I'll try to figure out next time probably.
okay, sure.
Thank you. Uh, so let's get started from here. So I want to touch base some of the uh, features that are newly released. Uh, MuleSoft 4.4 is available with correlation ID management and mapped diagnostic context. Feature flags are available. I think MuleSoft Composer was GA available GA yesterday, so that is another one. Studio 7.11 is available. That has a support for Mule 4.4. Secure storage is available with that, and database 2.4 support is available. So these are one few of the features that we wanted to call out over here. So I will be the one of the speaker along with being an organizer, and uh, Lee Feng Sai from Afolio from my team also gonna be one of the speaker, and Michael Brew is a senior technical architect at Afolio here, and we all three will be talking about the runtime fabric today. So let's talk a little bit about what is runtime fabric and how this is so important. So based on the definition what MuleSoft provides, the Anypoint Runtime Fabric is a container service that allows developers to run the applications across any of the environment with centralized management via Anypoint platform. So this is the official definition. In in simple words, the runtime fabric is a service that allows us or the developers to run the applications into the containerized environment basically. So we can isolate the applications, one application from another one through the containerization service provided by runtime fabric. Uh, so let's dive a little bit into what these are. So isolation between the applications by running at a separate mule runtime. So what this means is that we can have multiple applications deployed onto the same set of resources and that are isolated from each other. So they share the same server, but they are isolated from each other basically. Uh, these applications can have separate mule runtime, as in case of the if we are having the cluster, in that particular regular cluster, all the applications are running the same runtime environment. But in case of the cluster, in case of the runtime fabric, we can separate each and every application based on the different runtime. So one of the application may be running on 4.2, another application may be running on 4.3. So that is how the runtime fabric provides us the isolation between different applications. Uh, Scaling applications across multiple replicas. So what this means is that we can replicate the same application onto different nodes any number of times we want. So for example, if we are deploying a app onto the runtime fabric, we can specify how many replicas of that particular app we want to run. One app we can select that it is going to have two replicas. Another app we can select that it is going to have three replicas or four replicas. So runtime fabric provides that kind of a flexibility. So as we are having the uh, replica functionality, in case one of the replica is gonna fail, so another replica of that particular application is gonna automatically take over and continue serving the request that is gonna come to that particular application. So another feature of the runtime fabric is that application management is very easy. We can go to the anypoint platform and we can select uh, the different configurations of the application from the runtime manager directly. In the demo further, we are going to talk about each and every of these aspects. We are going to give you the live demo, how the isolation is happening, how the different versions can be selected, and how can we scale up the application and scale down the application. We are going to talk about how the vertical scalability is working, how the horizontal scalability is working, and how we can create multiple replicas. Uh, and we are going to do this live basically. We are going to set up the live runtime fabric. So there are mainly two kind of a main runtime fabric versions. One is the self-managed Kubernetes. What self-managed Kubernetes is that we can have our own cloud infrastructure. And so for example, we can go to Amazon Web Services or Azure Kubernetes or Azure or Google Cloud, and we can spin our own Elastic Kubernetes service or Azure Kubernetes service or Google Kubernetes. So we can spin our own Kubernetes. And on top of that Kubernetes infrastructure, we can install our own runtime fabric. And then through that particular can start deploying our own our, our applications. So in this, there are three nodes basically. So in context of the Amazon, we say we would be having the EC2 worker 1, EC2 worker 2, and EC2 worker 3. So then all those three workers are connected to the runtime fabric onto the Elastic Kubernetes service. So let's talk what is the challenge with this. The challenge with this particular infrastructure is that Elastic Kubernetes, the Kubernetes service installation management are very complex. So we need to have a specific team for this particular purpose so that they can, as and when there is a new release of the Kubernetes, they can upgrade that Kubernetes, and at the same time, if there is a new release of the uh, workers, then they can upgrade the workers. So overall, in this particular self-managed Kubernetes infrastructure, the management is very complex. So what that management is complex means. So in the final outcome of that particular implementation is that you need to have a separate DevOps team who can continuously monitor the applications and who can continuously upgrade the infrastructure. So we need to have a specific infrastructure team. So this was one of the option that we kind of explored very extensively. We've reached to a final outcome that it is going to take a lot of effort and it is going to take a lot of resources from our team. So that was one of the kind of a uh, conclusion that we reached to. uh, I'll take a pause, and I'm not able to see whether someone is asking for a question. Let me take a look into that. uh, Rajiv, I don't think, uh, I'm not sure whether I can open that option. Sorry about it. Uh, I don't know how to open that. Okay, I'll continue. Mm, okay, so further from here, let's talk about the VM bare metal architecture. So in the VM bare metal architecture, what we have is that uh, MuleSoft provides a ready-made set of scripts, and when we spin a VM bare metal RTF through the anypoint, it allows us anypoint platform allows us to kind of download the set of scripts that we can run, and that is the most important kind of a uh, comparison between the self-managed. In the self-managed, we need to spin the Kubernetes through our own Terraform, and we need to spin our own load balancer. We need to spin our own on workers and controllers through our own Terraform scripts. But in case of VM bare metal architecture, whenever we download those scripts, those are ready-made, and that kind of reduces the lot of kind of a manual work or kind of a support work that DevOps invest a lot of time into. And that is how it enables the developers to easily spin the uh, bare metal RTF. And we are going to see into this in the live demo, that when we spin the bare metal RTF, we get a set of the scripts, and within just 25 minutes or 15 minutes, we can spin our RTF very easily. While in case of self-managed Kubernetes, it is very hard to set up those scripts. It takes probably many days to set up those scripts by the DevOps team, and then the maintenance is another additional overhead on top of that. Okay, so this is in this particular architecture, we see here that there are three controllers and there are three workers, and although we can select any number of replicas in this particular diagram, we can see that application one and is having two replicas, that is deployed on worker one and worker two, and we can see application number 5 is deployed onto worker number 2 and worker number 3. So that is how we can have multiple replicas of a single application on different workers. And one more point here, that we need to have kind of a minimum three of the workers to have these replicas. So that is one of the important consideration. Okay, so far I have covered about what is the uh, runtime fabric and what is self-managed Kubernetes RTF and what is VM bare metal. So now I want to give you a kind of a sense that what is how we have modified this particular RTF for our need within Ffolio, and what is our journey going forward basically. So I want to talk a little bit about that as well. So we took the architecture of RTF that MuleSoft provides, and based on that, we have customized this based on our requirement. And we want very highly available applications, and just because of that, in our production environment, we are running 5 controllers, and we are running five. We started with 5 workers, but we have now more than 5 workers. We are kind of a quarterbacking the load into the controllers through the Amazon load balancer that we have set up through the Terraform scripts that were provided by MuleSoft. So in this architecture, this we are running the number of replicas based on our requirement. There are some highly available or there are some very critical apps that we deploy on more than 3 replicas, and there are some we keep a minimum threshold of number of replicas onto 2. So we do not deploy any app with less than 2 replicas. That gives us a very highly available applications. Uh, and here you can see that these blue circles are the different applications which are running into the different mule runtime environment. Okay. Okay. And from here, so far we have not implemented the failover mechanism. So in the next iteration, when we enhance our infrastructure, we are gonna kind of implement the failover mechanism, so that this is the next step basically where we are planning to uh, move forward. So this is going to be kind of a uh, in which recently we would have seen that there are kind of a one of the region, AWS region was down completely. So what happens to the runtime fabric in that situation? That is one of the very critical scenario that we need to consider while implementing the runtime fabric. So in this particular new architecture, what we are going to do, that for example, most of our applications are now hosted onto the east2 zone, and in case the east2 zone or east2 region completely goes down, we are implementing a failover mechanism so that all the applications automatically starts working or moves over to the starts responding from the west 1 region. So this is the next step that we are planning to implement on our runtime fabric. Okay, so with that, I want to hand over to my co-presenter, Michael Brew, to take us over to the different matrices.
Okay. Uh,
Uh,
it doesn't allow me to share the screen.
yeah,
Okay.
I'll
All
do
right. So, as anyone should when they're assessing a large investment like this, there should be a lot of research that's done. And we looked at a variety of the variety of MuleSoft options. We were sure we were going MuleSoft. It was just which option was going to be good for us. And we looked at a variety of those options, and then we looked at a lot of attributes of those options. So we looked at bare metal, Cloud Hub, self-managed cluster, and self-managed runtime fabric. We were, as we started, we were a self-managed cluster, and that's how we started out. Cloud Hub was an option that we needed to investigate, at least to see the pros and cons, and what would what would the impact be for the business, and things of that nature. And then, of course, we learned about the bare metal, and self-managed RTF were kind of where we were debating because those ones were pretty new to us. So we were looking at things like usage measurement, right? So when you're thinking about usage, there are, like when you're in a virtual environment, you have your cores that are on your servers, or on your virtual servers, right? And then when you're looking at Cloud Hub, you're looking at what they call vCores, and those vCores and cores each have a specific price point that needs to be paid attention to. When it came to application control, we really wanted to be sure that we could give enough resources to any of those applications. And we also considered that it could be that we would need an application that would need a lot of memory, but very little CPU, or a lot of CPU and very little memory. When you're looking at the vCore options, basically when you assign a vCore, it comes with a predetermined amount of memory. And I understand that it's configurable, but it's a little more difficult. Whereas with the bare metal, we're able to easily go in there and make those modifications. So bare metal was granular. Where we were self-managed, that was bound by resources. And what I mean is, if the server had 64 gigs of RAM, right? You cannot go over that 64 gigs of RAM. That's just the way it's going to work. So if all of your applications end up going to 63 gigs of RAM, which, by the way, is not recommended by MuleSoft standards, but if you were to like really overload it and then you got a really heavy job, it would basically crash your whole server and all of your applications would gun out. So that'd be a bad thing. So we definitely knew we wanted some granular flexibility as it pertained to the application control. For the environments, we Appfolio likes to manage what they do, and we have a team that is responsible for AWS as a whole. So they help any of the provisioning, any of the networking, any of the VPC stuff. They handle that. So since we already had an AWS footprint, it allowed us to have that as an option, which was very flexible for us. The only difference between all of them is that Cloud Hub is managed by MuleSoft. If I was working in an organization that didn't have an Amazon virtual private cloud, then possibly, MuleSoft would be a great option, because then I don't have to pay for those infrastructure costs. So it's something to consider. It was a consideration for us. For support, we wanted to make sure that we had the ability to react in a very timely manner. And then, of course, we rely upon our service agreements with MuleSoft. Cloud Hub, if something were to go wrong, the control by the end consumer is very limited. They have to rely on MuleSoft to resolve the issue, and they're usually very timely in resolving the issues, but it's not within the client's control, right? So that was a consideration for us, and along with the other two. The primary execution container. So understanding how those, the containers are actually the whatever Docker containers and stuff, how those are all managed. That we wanted to go with something that the people at our company had some familiarity with, even if they weren't going to be necessarily managing it. They were able to give us some pointers on, how is it going to work, in kind of the underlying software technology and controlling that's happening with Kubernetes. So that was very helpful for us. When we looked at Cloud Hub and self-managed cluster, those both were relying on AWS and EC2 instances. And we wouldn't have had much control, at least in the Cloud Hub instance. For scalability, of course, we wanted it ultimately scalable, right? We wanted it infinitely scalable, if you will. And so all of these solutions provided that. It's just in what manner did they do it? And so what worked for us is having the AWS footprint. And that was basically the same across all of the options that we were considering. And I'm going to make a caveat for the Cloud Hub, but very shortly. So CPU and memory resources, again, we wanted to make sure that we could have that granular type of flexibility with having more memory or more CPU or stuff like that. The Cloud Hub, it is scalable, but there's a cost to extra vCores, and so just as long as people are aware of that and that's within their operating parameters, it's a great option. But the when we were able to, like on Amazon, just purposely fail over an instance and then upgrade the memory and then fail it over back, it made it very convenient for us to be able to do that. Reliability. So again, we wanted to get away on the self-managed system. We wanted to get away from that shared reliability. In other words, if one went down, all of them went down. We wanted to get away from that. And that was actually the big draw for us for containerizing our applications. High availability, automatic failover, those things are all possible. It's just how do you actually implement them, and are you managing it? So like in Cloud Hub, you wouldn't manage that, which is great. Which again, if you don't have any like network engineers, that's great. But we needed to make sure that those things were actually available, and they were. And then of course, upgrade options. Sometimes if you've ever worked with like legacy servers, you have to upgrade something, you have to reboot the server and all this stuff, and it can be problematic if you have highly available and highly dependent jobs that are we're relying on servers, and they have to have uptime all the time. We had an option for rolling upgrades with the self-managed RTF and bare metal RTF, which was very nice for us. We wanted to be able to provide the services and be able to perform an upgrade without actually bringing the whole cluster down or bringing down all the services. Next slide, please. So again, more analysis, a lot of analysis that we performed. So for the staffing, it doesn't mean much to some people, but for us, we wanted to make sure that when we did something, there wouldn't be an additional labor cost associated with that. And in looking at all of the options except for self-managed RTF, we were like, oh yeah, we already do a lot of this stuff, so we're good with that. We can kind of squeeze this in. But with self-managed RTF, our Kubernetes team internally would have required or said that they couldn't handle the amount of applications that we have and that we were projected to have. So that meant that we would have had to hire a few people to manage the Kubernetes instance, and that was a consideration for us. As it pertains to logging, of course they all log. I want to put a plug in for MuleSoft. They just came out with this metrics app, and it's a self-contained app that you can get and you install. It's free, and then it will spit out a bunch of data. And with that data, you can look at it, and it will show you like who's hitting. Well, basically, the whole thing on it is that what kind of ROI are you getting out of your MuleSoft deployment? And so it allows you over time to look at, like, if I understand correctly, reusability of APIs, how much use are you getting out of those APIs and things of that nature. So it gives you very detailed data. And actually, we're in the middle of a little experiment with that. Code backup, all these were exactly the same. So we use a version control system, obviously, like every developer out there. And we just wanted to make sure that we could back up the code. Our company, and probably many other companies, have some audit or compliance regulations as it relates to any code and changes to make sure that they are able to be verified, that they were peer reviewed and approved and things of that nature. And we have that set up. So that was very important for us. Supporting API manager, I think the self-managed cluster does.
Yeah, self-managed cluster also supports the API manager.
I think we have to update that. So the API manager, I'm not sure if everyone's aware, but there's a tool called API Manager that allows you to set different security policies on your APIs to do things like, how many times are people hitting it and credentials and stuff like that. So it's a bunch of security stuff. It's important to, if you're going to be using that tool, to make sure that your things will support it. And we definitely intended on using that tool to make it, to make our APIs more secure and to have basically visibility into any of the policies that are implemented on our API, which is what one of the things that the API manager does. So we looked at costs. Of course, costs are a big factor. Costs with staff, without staff, and it without staff and with staff only changed on self-managed because we would have needed 2 people, and we just took a estimate of whatever 150 per person or something like that. Or 100, yeah, I think it was 150 per person. No, 100 per person, and the rest of them were just base costs plus whatever the MuleSoft costs are. So your support may vary from what ours are, and that's why we just kind of put it in there generically, because those MuleSoft costs that we pay may not be the same as anyone else on this call. Business continuity risk, and the same thing with business growth risk. We wanted to assess the risk associated with that, and based on all the factors that we just said, along with other options that are on the market, we assessed what our risks were as it related to that, and everything was low except for the self-managed cluster being medium. And the main reason for that was because of the fact that the resources could get overrun if it wasn't managed properly. So again, it's a consideration, and business actually really does consider risk very highly. And then business growth, additional costs. In other words, what happens if we have more applications on MuleSoft and a merger happens, or something like that, right? Well, we wanted to look at what would we need to do, and basically with the way we have set up things, if we have like 80 new APIs, or per 80, right, per chunk of 80 APIs, then we have to consider a new instance in bare metal, self-managed, and self-managed cluster and self-managed RTF. We'd have to consider those in 80 API chunks with the way we have our servers configured. With Cloud Hub, it looked like it was going to be around 5 APIs. So as we were looking at it and ensuring that we had the proper bandwidth or capabilities, it looked like we would be able to fit around 5 of our APIs the way it was looking at first. So what we did is we made a recommendation. We recommended that that AppFolio consider bare metal as the primary option, and Cloud Hub is number 2. And so now is when I want to touch on the Cloud Hub part. So we're going to have eventually some publicly exposed APIs where people can actually go and they can get to the APIs and look through our API marketplace. And in order to do that, they need a place to do that. And the Cloud Hub is typically the place that you would use to do that. And so that's why Cloud Hub came in as number 2, is because, well, one, it's the one that's managed by MuleSoft, and it makes our life a lot easier. But 2, we still need to use Cloud Hub to some extent to expose our public APIs if we want them searchable on the internet. So that was the main reason that Cloud Hub was number 2. The other self-managed cluster is kind of what we were moving away from, and that we were obviously not going to recommend the same thing we were on. And then self-managed RTF, just due to the additional costs and the fact that there would have been more moving parts to actually manage and to go wrong. So that's why self-managed RTF was kind of put to the side as well. So key features of RTF VM bare metal. And so, yeah, when we learned about bare metal, we were really, really excited because it seemed to do everything that we thought that we needed it to do, and it almost seemed too good to be true. So one thing is that RTF upgrades, right? So like I was saying, we can do a rolling upgrade, so we can actually upgrade and it will push out, and because it's on virtual instances or these different instance of the servers, it can actually self roll out and it can do that on its own. It's pretty magical. It's pretty cool. The high availability and scalability, again, this was a no-brainer. We had to have it. So the fact that we could not only deploy multiple replicas across multiple vhosts, right, but also the fact that we could actually split them up into different regions, like that's like infinite. That's like the dream of high availability and scalability. So we are very pleased with that. That is mostly like once it goes past the AWS load balancer, everything else is magically controlled, and we don't have to really worry much about that. And so that's it's very reassuring, not only to me but to management and personnel like that. So it's easy to scale not only vertically across those different like regions or zones within the regions, but you can also increase it horizontally. So you could just make it as thick as you want, and it's pretty amazing. And I think we're going to demonstrate that. We're just going to demonstrate that just how easy it is to actually scale horizontally. So yeah, this is talking about the upgrade, and basically you can scroll through the different versions, and you just click a version and say, apply changes, and it magically does it. Of course, under the hood, it's doing a lot of work, and I understand it's doing a lot of work because I've had to do these kind of upgrades before. But the fact that they've now automated it as it should be. Makes everyone's life a lot easier, especially when you don't want to be like, if you need to roll back, it's super easy to go roll back, right? Everyone's had an upgrade where it went wrong, right? You're like, I have to roll back. Well, to roll back is just as simple as upgrading. You just click the previous version and click apply changes, and it rolls back. So we actually tested that as well. So it's a very convenient thing that they have this. So overall, when we're using the bare metal, there's a low maintenance effort, right? Because it's all managed within the software package. They're managing the Kubernetes, all the stuff managed within there. We don't have to worry about that. The load balancer is all managed within there, so we don't have to worry about it. It makes our life really, really easy. So compared to what we were originally looking at, it was super low maintenance. Less and in our original implementation, we had to do the upgrades. We had to like stop servers and all that, and it was a night affair, right? So now we don't have to worry about any of that. It just magically does it. So we have less dependency on the operations team. So our operations team is the team that is doing the Kubernetes, and we needed to not impose on them because their plate was already very full, and they had their own initiatives to achieve this year. So they wouldn't have had the bandwidth for it, and well, now we're self-sustaining. That's very helpful, very nice. Everyone probably likes that. Comparatively to Cloud Hub, it was a lower cost for us. There could be instances where it wouldn't be a lower cost for some companies, and I can totally imagine that. And if other teams weren't as technically capable as the people that are at Appfolio, and I'm sure all your teams are awesome, but the team at Appfolio is very technically competent. So we were able to get away with managing it ourselves to some extent. And so, and there's no extra vCore requirements for API proxies. Proxies can be deployed to the worker. So we don't have to, we are not constrained by the amount of vCores that we have based on using virtual environments. We are constrained by our virtual environments, and that is something that was a super big benefit for us. I think, Rohit, I think it's up to you to ask the reframe.
Yeah, thank you, Michael. And in addition to those scalability points, I want to add a few more points that in case of the scalability, we can start with our minimum requirements. So for the production, MuleSoft's recommendation is that we can start with 3 controllers and three workers, and that can be the starting point for the runtime fabric. And as and when the business grows, the number of applications for the development team grows, you can either scale horizontally or you can scale vertically. So what that means is that based on the standard best practices, you should have a setup of 3 controllers and three workers minimum. And as business grow on a particular runtime fabric, you can increase the number of controllers up to 5 to make your applications highly available. And on the same cluster, single cluster, you can increase, you can horizontally scale your runtime fabric to add up to the 16 workers. So that adds a lot of scalability, and I think with a good worker node, 16 workers is a tremendous amount of kind of a resources availability. Okay, so with that, I think those were the few points I wanted to add on top of what Michael said. And I want to request Lee Fang, and this is going to be the fun part, frankly. We are going to, in this particular walk, we are going to start a new runtime fabric, and we are gonna demo here that within 15 to 25 minutes, we will be able to spin a new runtime fabric of type VM bare metal type, and we will be able to deploy the application in next 25-30 minutes on the existing runtime fabric. So it's gonna be pretty exciting. Li Feng, over to you.
Okay, thank you, Rohit. Let me share. Okay, let's go through the slides first. So in the walkthrough, I will first create a runtime fabric, and then we'll show you the script look like. And then there are some post configurations we need to finish before the runtime fabric is ready for deployment. And then we're using a CI/CD tool to deploy a simple Vue app. So
Awesome.
if you can stop sharing, I can share my screen.
Sure. Let me stop sharing, Li Feng.
Thank you.
Thank you.
Okay. So let me start from, this is, are you able to see the Anypoint platform?
Yes.
So to create the runtime fabric, we first choose the runtime manager from the Anypoint platform. Click on the runtime manager. And on the left panel here, you see there's a runtime fabrics. So click on that, it will shows all your runtime fabric. Even though the environment here says staging, but this is all for all environment. So to create the runtime fabric, you simply click on this button, and we'll give a name, RTF demo, and we'll choose the, there's a different flavors here as we went through earlier, and we'll choose the VMs, bare metal, and click on next. And you see there are 3 steps here. The first step, you can watch the installation overview if you want. The second step here shows there's a download files. And these are the files that MuleSoft provided to provision the AWS resources. So I'll be downloading the files, and let me go to here. So this is the file I just downloaded. Okay. And you can see in the directory here, this one for AWS. This is what the script we need. Let me expand here. The main file is fabric.tf. We will need to edit this. I can show this file. So this is the main script file, and basic define a lot of variables, including your cluster name, and also some key pair we need to provide, and also number of controllers and number of workers. So all this describe the resources we need for runtime fabric. If you want to use the default value, you can keep it as is. Otherwise, you can change any one you per your environment. Another thing I want to show you is, before we do that, another way, in addition to edit the file, you can also specify these variables from the command line. So that's what I will do today. So I start the terminal at the folder AWS. We need to run the script from this directory. To run the script, you will need two tools. The first one is the AWS CLI, so you can gain AWS API access. So the command I'm using is called assume role, and I'll give the super user role using the AWS assume utility. So this gives me super user role access to run the AWS API. And after this, another tool is called Terraform. So the script you see here is actually Terraform script. So these are basically, you write some descriptions about the resources. So Terraform allow you to define or write your infrastructure using code. So, and this is all done by, provided by MuleSoft. So we could just use it as is. So the command, I need to run the first command is called Terraform init. This will initialize the working directory of the Terraform script. Let me see, I can increase the font. Okay. Okay. So after initialized, and the next thing we will run is called Terraform validate. So this, you don't need to run this, but this is to see if your configuration file is valid. Okay, so the configuration is valid. So now the next step, we will run the command plan. The Terraform plan basically check if your execution plan match with your expectation. So let me run the plan, but I want to provide some of the command. That's the variables. These are the variables that later I will be using to create. So I want to run the plan with these variables. Okay, so these are the variables showing what the key pair is and what's your cluster name and how many controllers we are creating. So after the plan, it shows that it will create 40 resources and no changes, no deletion. So if this plan looks good to you, then we can do the final step, which is apply this change. So our using the same variables that I did earlier to do the apply. So you see there's a lot of steps. This is all running that Terraform script. So yeah, I think that's fine. So move this away, and then I'm going to run the apply command. Another step I need to mention is the activation code. So here there's an activation code. We need to copy this activation code to one of the variable called activation data, and that will link the Terraform script resources to this runtime fabric. So let me do that. Okay, so I'll run this. I do a, oops, copy Control C, sorry about that. Okay, let me provide the activation data. Give me a sec. So I need to provide the license. Okay, here. So I already put apply and with the same variables, and it shows the same result that we did for plan, 40 to add, 0 to change, and 0 to destroy. So I'm going to put yes to right.
And this is gonna start spinning up all the workers and all the controllers along with the AWS
Load balancer.
load balancer into
Yes.
the AWS directly from this terminal.
Yes.
And as we have given the keys to connect this particular runtime fabric, these particular resources to connect with the runtime fabric, we will see all these connected in the Anypoint platform as well.
Right. Yes. When this is done, this will when this is done, say ready for activation. So once all resources are created in AWS and connected with a runtime fabric in any point, they will show active status. And we can do some post configuration and also deploy the new app. So we can see here. Yeah, it's not created yet. So in the meantime, I think what we can do is this probably take about 5 to 10 minutes. And I also have a runtime fabrics, another demo. So we can do a deployment to this one instead while we are waiting.
Yeah.
So this is another runtime fabric we spin today. And the post configuration I mentioned first, we need to associate the runtime fabric with different environment. And you can choose debug, QA, staging, or production. This one, we only have one controller and 2 workers. So it's not recommended for production. That's why this is grayed out. And also the other post configuration we need to do is the inbound traffic. So by default, the runtime fabric does not accept any inbound connection. So we need to turn it on, and this will enable the inbound traffic. So what I'm going to show you next is, so this is Anypoint Studio. I have a new app. I'll change this revision number to 5. Our runtime fabric ready. It's still creation, so we can check back later, but I think that's the main demo I will show you.
Yeah.
Back to you, Rohit.
Thank you. So here we describe how to kind of I can start presenting, Leifeng.
Sure.
I want to go a little bit further and want to give a little bit more insights how to kind of horizontally scale or vertically scale the different workers onto the runtime fabric. So what horizontally scaling means that kind of how to add the additional node onto the runtime fabric, or how to, for example, there is a 16 gigs of uh, kind of a memory on a particular worker, how to increase that particular vcore for a particular worker. So I can explain that a little bit. So let me share this screen. So if you see here, this is a 3.1 core runtime fabric, and it is having currently kind of a 29 gigs of memory available onto it. And what we can do is just go to the EC2, and this is one of the worker, basically RTF worker, which is connected to this particular uh, RTF. So if I need to vertically scale this particular runtime fabric, what I just need to do is, sorry, I need to stop sharing a little bit, and need to put the MFA. Give me a moment, please. Let me share again. So we see here, this is a R52X large machine, and let me go here, check out other. So R52X large machine. So let's say this is another worker. This is staging RTF. So this is one of the worker of the RTF that is connected to this. And if I just need to horizontally scale, vertically scale this, vertically scale means to have more resources and processing power. What I can do, I can bring this to a stopping state, stop this runtime, this particular node, and in this meantime, so this is just like we are bringing down the application, or some of the application that is running on one of the worker, those are down. So what is going to happen in this particular situation, the another replicas that are deployed onto another worker, they're going to start servicing the traffic for that particular applications, or the applications that are deployed onto worker 0. So And if we see here, we were having 3.1 gigs. Just take a look into that. 3.1 gigs. And this is in a, let's check if it is in a stopping state. This is stopped. I can change the instance type of this particular uh, uh, worker, and I can change it to R5X large. So this is changed from R5 large to R5X large. And now I can start this particular instance, and slowly, once it become, the runtime fabric in the background will start detecting this particular node within few minutes or so. And with just two or three simple clicks, I have vertically kind of a scaled up my workers. So let's see if this particular node is up. Yeah, this is up and running. And we will look into this particular runtime fabric after a few minutes. So look at this. This has started showing downgraded because the the IP address of another node had changed because there is no elastic IP connected to that. We will look into this after some time. And now you have looked into this, the runtime fabric that Lifeng was working on, it is now coming up basically. So although it is doing some processing in the background, and it is trying to connect with these nodes. So these nodes will come up, and the status should be green in few minutes. Okay, so that is how we are having the vertical scalability. Let's talk a little bit about how horizontal scalability is gonna work. So for example, this is one of the node. So what we can do, we can just create another node. We can just copy this node and create another worker uh, of from this particular worker. And what it is going to do, it is going to copy all the resources that are available within this particular worker, at least the kind of a configurations that are available. And with just few clicks, if we copy this particular worker and create another R5X large or R5 large instance out of it, that will automatically connect the new worker onto the existing runtime fabric. Uh, so let's see if it has created the node. It is going to take some more time. So that is how after bringing down the worker and changing the instance type, bringing that worker back into the running state will automatically upgrade the resources onto the runtime fabric. So once this particular worker will be up, I can show that. Uh, and that is how we are having the horizontal scalability and the vertical scale. Let me come back to the demo. So that addresses are kind of a uh, EC2 worker. Let me, I have spoken about the EC2 workers. Let's talk about the controller. Where is our controller in the meantime? So we started, Leafing started with one controller and two workers. So this is the controller node that is servicing all the traffic basically. And this is available into the US East 2C zone, and another two workers. One of the worker is in US 2C US East 2C zone, and another worker is in US East 2B zone basically. So that is how we have set up. But this configuration is not for the production. As I mentioned in the beginning, you should have 3 controllers minimum for production and 3 workers minimum to have the high availability applications. Okay, so that comes to the controller. Let me check if we are having the load balancer. uh, uh, so Lifeng started one of the load balancer just now, and so this is the load balancer that we have started. So you can see that whatever configuration we started from the Terraform, those Terraform configuration has automatically started reflecting over here. Okay, so that is how our architecture for the controller, for the worker and the load balancers are, and it is straightforward from the Terraform script to spin these resources pretty quickly. Okay, so that I will check one more time if the, here we go. You see the runtime fabric is now up and running and it is in a healthy state. And um, it has 44 gigs of memory and 4.65 of the cores. Okay, so I have given you most of the visibility around runtime fabric, workers, controllers, load balancers, and how it is there into the Anypoint platform. With that, that concludes our presentation, that concludes our demo. Uh, let me check if there are any questions here. Uh, I'll look for the questions window for any of the question from you guys. Okay. Please ping me in the questions window so that I can unmute you or enable you to talk. Anybody? Okay, so let's have some trivia basically in the meantime, and if you guys would be having. Thank you, Ronnie. Thank you so much. Yeah, this would be very helpful. I think the way we can easily set up the VM bare metal that can open the gates for many of the people basically. So let's have a little trivia about what we have learned so far. So I want to have few questions during our from our session, and I will be giving kind of some of the certifications coupons, whoever answers these questions correctly. Ready, guys? Who is ready for the coupons? Okay, so good question, Noah. Basically, we can do that, scale up and scale down without stopping the instance. Yes. So if you can kind of take a backup or kind of for example, you are having another, you can take a copy of the worker node that can be a kind of a secondary worker, and bring that down and scale that down. Basically, that can be one of the option, but we haven't played with that particular kind of a way that without bringing down the supporting or alternate node. We did not we did not achieve that particular scenario so far. So in summary, if we take a kind of a replica of the existing node and play with that particular existing the subordinate node, bring that down and scale that worker down, and then bring that worker up, that can be one of the solution probably. But we have not, we are not able to do that without stopping the instance. Okay, let's have our trivia. I'll keep on looking into the kind of a questions window. So how many maximum workers are allowed on a runtime fabric? And whoever is going to give the right answer is going to get the certification coupon. Okay, let me check the window. Okay, perfect. Thank you. Let's see the answer. Good. Thank you, Rakesh. That is a good. Rajiv, thank you so much for that answer. Would be having another question. How many maximum controllers are allowed on an RTF? And one person is not gonna win both ones, basically. How many maximum controllers are allowed on an RTF? Okay, perfect. Let's see the answer. 5. I have another question. How many minimum production controllers and workers are recommended by MuleSoft? Okay, separately, how many controllers, how many workers? Okay, perfect. I think, okay. So here's the answer. So there are gonna be 6 nodes in total, 3 controller workers, 3 controller nodes and 3 worker nodes. Basically, that is recommended by MuleSoft. Okay, so that's it. Thank you. Let me check who are the winners so that I can work on the. So Rajiv, you are the winner for the first question, and Noah, you are the winner for the second question, and Niladri, you are the winner for the third question. Thank you so much for answering, and you will be getting your certificate coupons in your email probably soon. That's it. Please let me know if you have any additional question regarding runtime fabric, and I can share my personal email ID. If you have any question, you can follow up with me with your subsequent questions as well. That's it. Thank you, guys. Before wrapping up, let me know if you have any question. Else, we are good for today. Thank you, everyone, and have a good rest of your day and evening.